All right, I think we got it to work. It's green.
Who is
Perfect.
talking? Is that Seth?
That's Seth. How you doing, man?
Ah,
There's so many buttons here. I don't even know what to push. Good grief.
don't worry. It happens with age. It comes with the territory, Seth.
Hey, did you stay up late last night for any reason? I did a little.
I
Ju-
stayed up. No, I went to sleep. I went to sleep early, but I woke up at 3 a.m. Boston time to go buy this stuff.
I went to bed at 12. I stayed up until 12:01. But I don't
Oh,
know.
did you happen to purchase what you needed to purchase?
I believe I did because I actually went on there and then got everything set up and like I was good to go.
So the iPhone fairy came by last night.
Yeah, is your mic close to you?
Yeah, my mic's over here. Hey, Miguel, how's it going? It's Javier.
Hello, Javier. How's it going?
Good. So which size did you get did you go for the 512 or did you keep it reasonable?
512. No, 512 XS Black and Apple Watch 4 LTE chip enclosing.
Nice.
Yeah, I looked at because I have the 10 and I'm not even using half of the memory that I have and I'm just like, you know what? I don't need the big one. So I got the iPhone XS Max something. Like I don't did one of our marketing guys
Yeah.
go over to Apple and start naming things over there?
Yep, I agree. That did happen. No, I did the same thing that you did. I looked at my storage, and the problem is that I have 256, right? But I only have 20 gigs left, free space. So
Oh,
to me, it was, I reached my limit. I've reached my limit.
fantastic. All right. So, I want to get into what you're talking about today because I saw this project. I don't know. You told me, I don't remember when I saw you, but you were like, in my copious amounts of free time, I decided. Oh, sorry, I'm too loud. Someone's like, their ears. I'm so loud. I'm sorry. How do we turn me down? Mic number 2. I'll move away. I'll move away. Thank you. Okay. So you said in your copious amounts of time that, am I too loud? Oh, they say I'm way too loud. Gosh, you guys know me, right? You said in your copious amounts of time, you spent some time building something, and that's what you're talking about today. Is
Yep.
that right?
It's one of the things. I'm gonna talk about 5 things, and that's gonna be one of them.
So can we turn his audio up too and turn my audio
That's
down?
what I'm trying to figure out.
Okay, he's figuring it out. Okay.
Stop yelling.
Yeah, I'm not yelling. This is my normal voice.
Yelling.
Like, have you never seen me on the television
Like that.
before? I was on Cops once, Javier, but my face was blurred out, and I was in the back of the car. I was yelling at that time. Thank you. Yeah. So I'll go a little bit less loud, but we're going to turn the time over to Miguel to talk a little bit about retro.net. You're up, buddy.
All right. Hello, everybody. My name is Miguel de Casa, and today I'm going to be talking about retro.net, which is a collection of tools that help you build great mobile applications. So some of you might not know this. Are we are we live?
Yeah, we're still going, buddy. We can
Oh,
still
are we
see
live
you.
or not?
No, we are. We are. You can see us.
Oh, so okay.
Yeah.
Yeah, all right. But this is being broadcast. That's the question.
Yes, you are still being broadcast. Everyone's loving what you're doing.
Oh, all right. I'm sorry. Okay. So, anyways, I want to talk to you about retro.net. And, as I've spent a lot of my life working on Unix. And even despite the fact that I work on the Linux desktop and I work on mobile applications, the console is still the place where I do most of my work. And over the years, I had to write a lot of little apps on the console, and I keep working on the console. This is my file manager. What you see on the screen, this is still the way that I work every day. So let me show you. Let me tell you what I want to do. So today I want to cover a couple of libraries that I've built or that my team has built that help you build good developer experiences. And I also want to tell you how you can turn these applications into something that you can use as a tool in your system. So let's get started there. So first off, I want to talk about three components. I'm going to say there's three pillars. The first one is writing tools that integrate with your environment, whether it be Windows or Unix, and that starts parsing command line arguments. Right, so that's the first piece. The second piece is going to be once you have one of the tools, sometimes an interactive tool, not a full desktop, not a full console application, but something that needs to be like a shell. So we'll talk about that. And thirdly, we're going to talk about building GUI applications or terminal user interfaces on the console. So let's get started with command line parsing. So this is my go-to library that I use for building command line applications. And the idea is that when you write a command line tool, you want one of the most common tasks is parsing the arguments that are passed as the string array args to your main. And you want to integrate properly with the environment, and that means these days the convention on Unix is dash and a letter short option and space and an optional parameter, or dash dash for a long option name equals and the value and any other arbitrary thing. So instead of having everybody implement this over and over, we wrote this little library called mono.options. It is not linked to Mono. You can use it on .NET Framework, .NET Core Mono, and it's available as a NuGet. But also something that is very interesting. This is a library that is implemented in a single file, so you don't need to use a NuGet if you don't want to. You can just also use your file on its own. Let's walk you through a couple of things that this library does. So this is I extracted this out of a little tool that I wrote recently, which is a implementation of netcat. It's just a little program that takes its standard input and sends it over the net, or can get data out of the network and send it to standard out. And in this particular case, this is how you define the option. So let's walk through a couple of examples. The first line says that defines the option 4. That means that you can pass the option -4 to your application, and you can invoke this little method in particular in this lambda here. And all this does at this point is set the variable, this boolean value IPv4 to true, right? So these are the way that you define what happens when these options are passed. So you can do any arbitrary thing there. Let's go to the fourth line. On the fourth line, you see that there's a little L and then the pipe operator and then listener. What this does is it defines two possible ways of invoking this option, either with a shortcut, right, with a single parameter -L, or passing --listener, right? So in this case, it would accept those two options. You can also notice here that all of these options have help. This is a string that will be used when you need to get help, right? When you invoke the command and you request some help, we automatically generate that list of options. Now, the next line that is also interesting, I want you to look at this. It has this syntax, P and then the pipe operator port equals. And what this means is that it's telling mono options this parameter, this option takes a parameter, right? The way that I described it before. So and the rest are just other things that are just right. But these are effectively the ways that you define options. Now there's a lot more power, but we're going to get started there. And this is an actual invocation of the application, and you can see how this is used in this particular case, right? You see the -6 short option, -p, and then a space 3000, again, a short option. Then you see --psk equals secret. This is the format they use for a long option. -t, that meant please use TLS. And then you have these additional strings, www.microsoft.com HTTPS, that are not linked to any options. So those are, we'll get to that in a second, those are returned from the parsing library to your application. The second line shows a different way of invoking something very similar. Again, it shows the use of the long options, --port equals 3000, which is equivalent to -p, and --TLS, which is equivalent to -t. So now I'm going to show you how this works. So what you do is you call the parse method on the options, and you pass the arguments that you received in the command line. And the return is an IEnumerable strings, and this is the and this is everything that was not parsed as an option. And in this case, I just happen to have implemented the convention that the first parameter is the host name and the second parameter is the port. I am choosing in this particular case to default. If the user does not provide the second parameter, I make the default be HTTP. That's what you see in case one. And if you don't provide those two arguments, which are kind of mandatory, I show the help, right? And we'll get that in a second. But this is basically the way that you build this command line option. So when you run this thing, if you wanted to show the help, you invoke this method, write option descriptions. You pass a output value, right? In this case, I want to send it to the console.error output. And this is what it looks like. So when you invoke this, when you invoke the command with no arguments, essentially we say, hey, this is an error. So we display to the user a list of possible options that they can use, right? And this is is generated from the data definition that you saw. Now, one thing that has happened in the last few years, for example, is things like the git command. Let me go here. So the git command, it's now kind of a collection of commands, right? So if I say git commit, it's actually or git submodule, you see that it's actually a family of commands, and there's a couple of interesting elements here. First, this is the subcommand, the main command, and then you have these subcommands: add, status, init. There are flags that apply to everything, right? These ones that go before. And there are flags and parameters that apply to other ones. So Mono.options has full support for these nested commands. We call them command sets. And when you create structure, not only you can pass actual definitions of your commands, but you can also pass strings. And those become part of the standard output, right? So for example, you say that if I just define the string, this gets copied to the standard output as usage, right? So you say usage, git version, etc. You can see that out there. So this is a nice way of formatting versions and getting an automatic display of the things that you have. But what is more interesting here is that you can nest them, right? So you can have a new command set submodule, and again, it can get its own help. You can embed the help with your command definition, and then the commands that you want to invoke, in this case, init, add, remove, with the same patterns that you saw before, right? So, and another thing that we also recently added is support for this for any commands or subcommands to actually have spaces in their names. So, if it just happens that for user experience, you desire to have a space in the middle, you can certainly do that. So you could say submodule or subspace module if that's what you want. So that's command line options parsing. It's very interesting. You should go use it today. Now, the second piece is a lot of the tools that I write or tools that I use on a day-to-day basis have to do are interacting with the user in the command line. So, for example, like the shell. So let me go back to my terminal here. Maybe I should make this a little bit bigger so you can it's better. For example, I'm gonna use this the interactive C# interpreter. Here I can issue C# commands, right, and get the result. But what is interesting is that I can use the arrow keys here to go back and edit the command line and maybe make some changes. But also I would like to get code completion on the shell. So if I press dot, I would like to get completion the way that you expected. Something that you can't really get with console.readline. So this is the second library that I want to talk to you about. This is called mono terminal.edit. But before we get there, I want to give you a sense of the kind of challenges that we need to cope when we're building these console applications. When you're interacting with console applications, you don't really know very well what's on the other end. Now, most people and most simulations are based on the VT100 set of escape sequences and the protocol. So many of the terminal emulators that you use, meta terminal emulators, are essentially supersets of the VT100. And there's a big evolution of these things. But what you have to remember is the VT100 was a terminal that only did black and white. And the idioms you use and the idioms that were used at the time included things like bold fonts, things like reversed settings, which basically swap white black text to be black and white, right? So it was kind of limited in what it could do, blinking, right? Uh, and you still need to support this because not every terminal emulator that will connect to your application, either on the cloud or on a server or something else like that, will support the full spectrum of colors, right? So nowadays you have True Color on Windows, you have True Color on Mac. So things have changed a lot. But you need to keep in mind that when you're building terminal applications, your application needs to work in this different set of environments. So the thing that it's one of the things that is interesting is that is that over the years we've added new capabilities, essentially the VT100 core, and they're typically identified as external. And it's a superset of the VT100 set of escape sequences, but they support mouse events. So that means that they can receive clicks, they can receive double clicks, they can track the mouse position. Some of them contain colors. We'll talk about that more in a second. And and uh, some of them can even do more interesting things. Can display full Unicode text. You got to keep that in mind. So now, it's really not a problem of dealing with the console on Windows. You have the console API, but on Unix it's a little bit trickier. The way that a console application knows what it's building, it doesn't really know what's on the other end of the connection. And the way that attributes and capabilities are determined are based on the term environment variable. So there's an environment variable called term, and based on this, applications tend to look up into a system database called term info. What kind of capabilities are there? So I'm going to show you what this list of capabilities. So this is my terminal. It's an xterm -256 color. And if I run the command infocomp on Unix, this will dump all the database of capabilities of this terminal. So this is everything that we know about this terminal. And, some of them are attributes like, for example, the number of colors that the terminal supports, the number of columns that it supports, the number of lines. We'll get back to that in a second, because you see that my terminal is actually a much larger. It's actually 119 by 29. And here it says 80 by 24. So we'll talk about this in a second. There's this concept of pairs, and we'll return to this later, 2,000 pairs. And some of these are escape sequences that are used for particular things, like clearing the screen or moving the cursor to a particular position. And some of the others declare things like what kind of escape sequence is sent when the user presses one of these keys. Like, for example, keys say UP, arrow keys, some of the function keys, right? When you press function key, you get an escape followed by an open brace 18, 2 tilde, right? So this is the database. Now, I can show you that the database for the VT100, by changing the environment variable, it's a lot more limited. It fits on the screen, right? So it's a lot smaller. And so applications actually rely on this information now to gather capabilities. Now, there are a couple of other items. In particular, this one, you can see right now that the environment variable lines equal 29 override the information from the database. So the database says, hey, you have 4 lines. Well, in reality, you have 29. And not only is this information available on environment, there is also this I/O control operation that you can query certain terminals. So sometimes the kernel, the operating system, has this information. So typically, the way that it works is that the most advanced applications will try the I/O operation. If that fails, they'll fall back to lines and columns. If that fails, it falls back to terminal capabilities. So the I/O control operation really doesn't work over serial lines, but it works over pseudo terminals, SSH, emulated environments. Now, like I mentioned before, one of the challenges that you have in this space is not only that you're dealing with old, very old terminals that barely anybody uses, but that a lot of the people that have written terminal emulators have really limited themselves to the original set, right? So these are the operations that you have: blink, bold, reverse operations. Then some people added 8 colors, right? So you got 8 colors for your foreground, 8 colors for the background. Some other people added 16 colors, and that really means that they added another the highlighted, the bold versions, high intensity colors for the foreground. Other folks like my terminal right now, they support 256 color palette, and lastly, the thing that most everybody is moving to these days is supporting 24-bit color, right? Now the challenge with some of we have a couple of challenges here, which is that some of these concepts did not exist when the term info database was shipped, and the libraries that consume this database have not been updated on many of the operating systems that you connect to. So, so for example, while the ncurses library is a library, is a go-to library that people use to talk to your terminal, and it's actively maintained and has all kinds of new capabilities. The problem is that many of the systems that you connect to use an old version of ncurses, and the API has not remained. The ABI of this library actually is determined at compile time, which means that two systems might have an ncurses of the same version. They have different ABIs, right? So there's different ways that people have solved this problem. I'm not going to get into that, but one of the challenges that you face when you're building these applications is that the system libraries might not be up to date, right? So some people have taken the approach that they just read the term info database directly, circumventing these dependencies. All right, now when you're building these applications, I think that the first thing that you want to do is, if you have very basic needs, you're not a man of big desires, you can just use the System Console API. The good news is that we support this on .NET Framework, .NET Core, and Mono. It does the basics, reading, writing, and it has a limited interactivity capability through the read key API. You ask read key to either echo the character or not echo the character. Lighter being kind of the approach that you use for making nice and neat interactive applications. It is limited in that it only supports cursors. It does some cursor positioning, but beyond that, it has a lot of limitations, and we'll talk about those later. But in particular, it's an API that doesn't even serve all the capabilities of the Windows console. So it's really a subset of the things that you want to do in a modern console app. And like I said, also the other problem is that it's really a bad match for Unix. It doesn't really work well with Unix. In Windows, there's this concept that you can draw to any arbitrary position on the screen, and the display gets refreshed at one point. In Unix, actually, if you want to update a piece of the screen, you must first send an escape sequence that moves the cursor to that position, and then you write your text. So this is a little bit challenging because it's not very efficient. You want to constantly change the cursor position to right character. You want to accumulate all the data and then have a flush operation that optimizes just how much text you send, right? And really the big problem is that there's really no reasoning at higher levels about this, right? You really have to roll your own. So we'll talk about some of the things that you can do today. Things. So interactive line editing. This is the demo that I just showed a second ago. Is how do you write applications that are a little bit better in read line, right? If you write an app, let me show you. If you write an app today, just calls you don't really get a good experience, right? So I'm writing hello world here, hello world, and I try to use the arrow keys. It doesn't really move, right? And I can't really do much. I cannot really edit this thing. I'm pressing the arrow keys, nothing is happening. So this is the kind of experience that you get with readline. It's not great. So what you can do in this particular case is you want to use a library that can replace this. In this we have the mono.line edit library. Gives you the editing of your input with the cursor keys. It also has Emacs key binding, and that's because we're Unix. I wrote it. I'm a Unix person. It also uses most of the Windows bindings. So, the home cursor and, home key, end key, left, right, control left, control right, all that stuff works. But most importantly, in Unix, where some of these mappings are not available on every terminal, we use the Emacs key bindings, right? And the other capability is that it also has a feature that can save the history of all of your commands. So it really, it's very close to the libraries that have been used in Unix for many years. So we save the history, the library saves the history and can restore the history next time that you start it. So you provide an identifier for where you want the history to come from. And also it has search in the history, right? And like I showed before, it has optional completion. So this is how you use it. Create an instance of the line editor class, right? You provide ID for the history, right? And how big you want the history to be, right? In this case, I want to keep 300 items in the history, and the history label is maybe my app history, right? And then you just call the editor.edit. The return value is the string, right? And uses the prompt that you. Now let me show you, right? The history in action, right? So if I invoke the C# library, the C# command again, and just press the up arrow, you can see that I can go through my history of things that I've done. In fact, I don't even know what I'm doing here. Look at this. Yes, a few days ago I was testing some bug iOS. But you can just go through the history here. Now, the other thing that is interesting is that it has search. So if I press the Control R key, when you press Control R, it enables reverse incremental search. So as I type, right, A, S, right, it goes through history and finds the match for I was looking for, in this case, assembly. Or I could try, for example, C, console. I press Control R again and try to find the previous history. So I keep pressing Control R, and it will keep going through all the matches in history, right? So that's a history search that I just showed you. I should have waited for this thing, but I have a nice cheat sheet that you can use later to remember. Now the completion I showed you a couple of minutes ago, that when you press the dot on the C# command, you actually get a list of valid options that you can use. I'm going to show you how you wire up. The way that you wire this up is that you set up this delegate. You hook it up to the autocomplete event, and this delegate gets a string with the full input at this point that the user has entered. So it's really whatever you want to show, and the position where the cursor is inside, right? In this case, implementation is super simple. I just happened to call the C# compiler and said, please give me the completions for this at this particular point, right? So in this case, I extract the input, the complete string there. I cut the input string. I only interested in everything up to the point where the cursor is, and then I'll tell the compiler, please give me a list of completions. And your job inside the delegate is to return, right, an object of instance of the completion object that provides both the prefix, right, and that essentially gives you all the elements that were identical in the list and an array of the completions. And that's all you have to do. Then you can implement completion. The one thing that you have to keep in mind here is you see this little line here at the top, the second, heuristics modes equals C#. The default behavior of the line editor is to provide completion when you press the tab. This is very similar to what you would get on Unix shell, right? You want to get completion, you press the tab key, and then it kicks the autocomplete event. The heuristics mode, all it does to enable C# is that it also triggers automatically the completion when you have a dot. So if you press a dot, it automatically triggers it. And in this particular case, it's smart but string, so it doesn't trigger it inside a string. So you can remove the heuristics mode, and you would get the default shell experience to this. Now let's move on to the most exciting piece for me, which is text user interfaces. So this is a library it's a labor of love. The other two libraries have existed in Unix for many years, or in the .NET world for maybe 10 years or more. This is a library that I tried building some maybe 6 years ago. I can't remember, 6-7 years ago or 8 years ago, and kind of abandoned it at the time. because Silverlight was happening, and Silverlight was the hot thing at the time. And now that the cloud is big and uh, SSH is back in vogue, I decided to that thing. That's why the project was called GUI.cs. The UI toolkit used to be implemented in a single file. These days, I split it up on many ones, right? So the project is called terminal.gui, and it's essentially a toolkit for building these kind of applications, right? So what you see here is is one of these apps, and it shows just a collection of UI elements, right? Uh, Labels like login and password, entry lines for entering your login or your password, checkboxes, radio buttons. You can see them. You can choose between personal and company. Buttons like and cancel, a menu bar at the top, right? So this is the kind of thing that I wanted to build, and I wanted to create a lot of these applications, right? And you don't want to build this yourself. You don't want to paint every element. You want to recreate all of these things, handle hotkeys, mouse, events, and so on. So it's really, you have to think about terminal.gui as a UI framework, similar in spirit to what you use when you're building desktop apps or mobile apps, but for console apps. Right. So the code that you see on the left is implemented roughly with the code that you see on the right. So let me walk you through a couple of interesting elements here. The first one is, you bring the terminal. The second one is that before you get started, you need to call application.init, and that determines which driver to use. We'll talk about that later. It determines how many colors are available, which styles are available, which attributes you can use. Here's the application for running. Then here, the next line is our topical application type. It's just a convenience. I want to be able to conveniently to the top level view of the application. I will talk about views in a second. Then I create a window. I created this type of rectangle. We'll talk more about that in a second. But essentially, I create a window that doesn't cover the first line. So I say, give me a frame that covers everything but the top, and I give it a little name. Then I add the result. Right? So turn up window. I add that window to the top. Then I create the menu bar, and I add the menu bar to the top again. A couple of items here to look for. The underscore is in front of the letter highlights the letter in the UI and also makes it a hotkey. So if the user presses that letter, it activates that entry. And then you can see how I created a bunch of the elements in the UI just by creating instances of these views and adding them all to the window. And finally, I call application.run, which triggers the main loop. So, some of the things that GUI does, so we've covered some of the elements in this slide, but some of the things that are worth keeping in mind is that the library takes some of the limitations that exist in terminal apps today. For example, some old terminals or emulator lack the mapping of the alt key, right? It deals also with the challenge of terminals have colors and some of them don't have colors. So at startup, I set up a set of styles that you can use and you can reliably use on your app so that it looks correct and works properly. On systems that support it, we automatically handle the library automatically handles resize of the terminal. It takes care of input events and running your main. As you use the API, you'll see that I've actually taken many ideas from the iOS UI kit design. So if you use UI kit, you'll be familiar with a lot of the concepts. And you see that I borrow extensively ideas from GTK and Windows as well. Now, application.run is the thing that makes your application tick, right? It provides a main loop. What this means is the application.run is in charge of fetching input events, and that can be keyboard input or mouse input. It also handles timers. So if you want to have an application that methods that get triggered every 10 seconds or every minute or every something, you can register there. You can also have a method be invoked when the application is idle, when there's nothing else to do. So you can have a method that is continuously invoked when there's nothing pending to do. On Unix systems, we can also monitor file descriptors. This is not possible on Windows today, but we can monitor whether a socket is ready for reading or writing, or a file is ready for reading or writing, which makes it very convenient for building event-based applications, right? So if you want to say, hey, notify me when the socket is ready, and you forget about this and you don't want to create a thread, you can do it here, right? The library also handles a semantic for Unix suspending. So in Unix, when you press Control Z, your application is supposed to reset the terminal to a sane state, get you back to shell, and then when you press FG, it's supposed to bring you back to the application, right? So let me see back. Like this, right? I have an application. If I press Control Z, it suspends the app, right? The app is suspended, and if I press FG, foreground, it brings it back to life, right? So the framework takes care of this. The other thing the application run does is that it's in charge of managing the focus, drawing the focus, controlling the focus, and sending events to the proper views on the screen, as well as redrawing affected areas on the screen. Now, a common idiom in Unix is to press the Control L key. So sometimes you're dealing with a terminal, either because noise on the line or background process is writing stuff to your screen. Like, for example, I could write something like while true, do echo slip E, right? So this thing is just going to keep spamming my terminal every 3 seconds, right? Actually, let me make it faster. Get better, right? So every second, right? So sometimes you have an application like this one, and there's a background process that is spamming your console, right? And so a common idiom on Unix is that you press the Control L key, and Control L should always refresh the display, right? So this takes care of the application framework already takes care of this for you. The Control L is already hardwired for you as well. So keyboard input on Windows, everything in your works expected. There's really not much to do there. But on Unix, like I said, we're dealing with a wide spectrum of systems. And some of the challenges that you have with the keyboard input is sometimes there are no function keys, right? There are no function keys, but you want your user to use function keys. And it's not obvious how to map them. And some terminals do not have a notion of alt keys or escape keys, or they are misconfigured, right? Or sometimes people don't know how to configure these things. So GUI.c has those two things for you. First, it maps the sequence escape plus a number, right? So pressing the escape key plus a number is mapped to function key, right? So if you don't have an F1 keyboard, or you don't know how to get it, or you're on an iPhone, or SSH something, and you don't know how to send the F function key, you can press escape and a number. Actually, it's a good point. If you're using an SSH client on the iPhone, some of the clients do not have, or Android do not have F keys. The other one is alt combinations, right? So if you want to say alt X or alt S or anything else, pressing escape plus a letter is mapped also to letter. And this, for those of you that use Emacs, you'll know that this is exactly what Emacs does. And this is interesting because in dialog boxes, you want to, in the DOS era, you use alt plus the letter to automatically focus or activate that particular control, right? So everything that has a hot spot, right? Hotspot or things like, the hotspots are anything that has a different colors. For example, compute totals, the hotspot is L. So if I press L, the focus goes there. Or if I press E, it takes me over there, right? So those are the hotspots. Now, the system is built on this concept of views, right? And this is the very same concept that you have on UI view. And these views have a frame, and the frame defines the whole region that the view will cover on the screen. And you can assign it in two ways. You can set the absolute frame. So when you create your object, you pass a rect object, right? And this sets an absolute position. Right? If you create a rect, if you pass a rect parameter, it will set an absolute position. Or you can set the X, Y, width, and height properties manually. These are not integers. These are magical. So we'll talk about magic behind X, Y, width, and height in a second, right? Another thing to know is that the X direction moves left to right and the Y top to bottom, right? Now, one notion that came directly from iOS that views can have nested views, and those in turn can have views. So it's a composable model. When you build a compound user interface, you just can compose these by adding views inside each other. And the focus system works by navigating trees. So it's a visual appearance that the user will see. So what we do is we walk the tree hierarchy. Well, not the user sees, but we walk the tree hierarchy and try to give the focus to the next view in the hierarchy. And if there is no view, no more contained, for example, in this case, these two orange ones inside the green one, inside the white, the yellow one inside the orange one. If the last one was focused and I press the tab button to move to the next focused item, it would try to focus maybe the green element on top. If that element is not focusable, right? Oh, no. It will go to the next logical one. In this case, since it's the last one, it will go to the green on top, right? So it tries to follow it follows the order in which you created the views inside each one of these. Now, not all the views are focusable. This is something you can control. So we'll get to that in a second. Now, some things to keep in mind. These are some of the core types of the framework. There's 3 structures. One defines a rectangle, another defines a point, and another defines a size. And you use this in a bunch of places. So, for example, the frame object is of type rect, and it represents the absolute position that the object currently has, right? That the view currently has. So let's talk about layout. Like I said, you can pass a rect object, and that will be an absolute view of your, the absolute position that you want to give your view. And the problem with this is that once you do that, you're on your own. If the user changes the terminal size, if view changes its size for other reasons, you have to manually change the frame of every view, like a caveman, right? So, and you have to do it by overriding the layout subview method, the view that made the poor decision of making them absolute. The other thing that you can do, and this is something that I struggled, I figured, do I want to have a layout system that measures the objects, or and each object does the whole protocol? What is your desired size? How big can you be, right? What is your desired size and your minimum size and your maximum size? And then implement stack views and stacks and boxes and tables. And I felt that was too complicated for this. I felt I wanted to do something simpler. And I came up with this idea. So the X and Y properties are of this type called POS, P-O-S. That stands for position. And the width and height are of a type called the other nice thing is that any integer values are implicitly convertible. So if you really want to just set the x position to 0, you just say x equals 0, and that will anchor the value of x to 0, right? There's no interesting stuff going. But you can do a lot of really clever stuff if you use the pause and dim position. So let's take a look at pause. There's a number of static methods in pause that you can call. So if you call, for example, pause.percent and then number, right, it will give a percentage. It will return a percentage within the container, right? So you can use this to position elements at a percentage inside your container view. Or you can say anchor end, which will essentially give you a position that is computing from the right side of the view, right? You say anchor end 0, it will give you the right value, right? Versus 0, which is always the left, right? So you don't really need anchor start because it's essentially just setting the x to an absolute position, right? You can use center to get the center within the container of this view. And the interesting thing here is that the operator plus and minus are overloaded. So it lets you do things like, for example, center minus 10, right? Or left minus 4, right? And so on. Now, the 4 next that come, left, top, right, and bottom, these let you poke at the left side of the specified view. It can be the container view, it can be one of your peer views, right? And we do a topological sort here. I do a library. We do a topological sort to identify, to compute this thing. And if you have cycles, of course, you're going to get an error. But essentially, you can say, the position that I'm going to set is going to be relative to the left, the top, the right, or the bottom of this other view. So that's why I have to compute this thing, right? And dimension is very similar, right? You have like fill, right? That will perform a fill based on top view, right? Or can set, and you can also do the same operation. So let me give you a taste of what it looks like. Right? So for example, in this scenario, I'm saying I want to log in. I want the X position to be centered. I want my column to be centered in my container, the Y position to be 6. Now, the password, it's a table that really should come, below, right? It should be aligned with the first one. So what I'm saying is, give me the left side of the previous two, right? But I want the Y to be just one below. So I say, give me the bottom of the login and then add one space, right? And you can see how this works. On login text, I actually go and say, well, give me the rightmost position of the password and give me the topmost position of the login. That's how I configured it. And I said I hardcode the width. And you can see how this is used, right? You can see on past text, right? The element. My X position is relative to the login text. My top position is relative to the password, right? That's how I align it, right? And so, and the last example just shows, just fill the whole screen, give me one space back, right? So this is the kind of this is the layout that the layout we have, and it's simpler to understand or simple to configure than other systems that iOS platforms have, where you can enter a particular point and you have to pass all these flags. In my mind, this is a lot simpler to think about, and I'm quite proud of this thing. Quite proud of this thing. Now let's talk about another. So I already use. There's a special kind of view called the top level, and they're only special because they participate in model event handling. This is important when you pop up a dialog box and you want to use it to and you want to capture all events. You don't want events to go to other elements in the UI. So when you pop up a model view, you don't want the mouse to click outside of this particular top level and the event going to the one behind this, right? So you need to pass a top level view to application level if you want to run one of these, right? There's two kinds of top level, really. The top level, which is just an empty top level, or the window, which is just a top level with a nice decoration title, and dialogues, which are subclasses, right? Now the views, like I said, every view by default determines whether it can be has a focus or whether it can be focused. Some of them hard code, right? Labels, for example, write this method and say, doesn't matter if the set method, I can never focus, right? Some of them you can control whether you want to focus or not, right? For example, if you disable an entry, you don't want it to be focused, just set cancel, right? And then at the core of all these views, there's these 4 methods. Every time that there's a key, the system first goes through all the views in order, right? And it says, hey, do you want to process these as a hotkey? This is when you say escape letter. First, you give a chance to everybody to respond to the hotkey. If nobody responds to the hotkey, then you process it as a regular key, right? And if nobody responded or wanted the key, then you say, hey, I have a cold key about to throw it away. Are you interested in this? And finally, the last event is the mouse event. You can notify when anything happens with the mouse. And the mouse event structure contains information, clicking or moving or stuff like that. Now, let's talk about color, because this is a challenging topic. You don't really use colors without direct. Although some classes surface convenience, you really want to think in terms of attributes. And an attribute abstracts over both the foreground color for the cell and the background color of the cell, or the black and white description. And this is why it's important, because when you build your application, you want your app to work both in color for terminals that support it and terminals that don't support it, right? At startup, I create a bunch of these for you. So out of the box, there's already a set of styles. I've only defined 1 styles. I would love if somebody else contributes more styles, but it's important that you build your app like this, because you want your app, right? The one on the left, as you can see, you can still use it if I forced in the left side the terminal to be VT100, and you can still use it if you have a limited emulator like the one built to Emacs, for example. On the one on the right, you have a more capable terminal, so you can use all the colors. So as far as the views are concerned, we're actually just dealing with attributes, and we're dealing with them in a couple of ways. But before we talk about this, about how they deal with them, I want to look at one particular set of views here, because you'll notice that you actually need a bunch of different colors for this UI to work. For example, remember me, right? Right now it's not focused, and there's both a hotkey, the R, and then there's a regular text. So you really need two separate attributes. You need one attribute for the hotkey, one attribute for the regular text. And you can see that the second lane is focused, right? You want to give the user an indication that this is where the focus is. The focus is shown in two ways. The cursor is shown in the right position of the view, but also the label is painted differently. And you see here again, the attribute for the hotkey is different than the attribute for the text. So we're really talking about four colors. So this is what I call the normal color. This is called the normal color. This one is called the hot normal color, right? That's hotkey applied to the normal text. This is the focus color, and this is the hot focus color, right? Those are the four colors that you use. And I call these things color schemes. And by default, the set styles that you have, you want to use, today I have 4 different styles. You can see 3 of them on the screen right now. The base scheme of colors, so all the views use a scheme, and they inherit their scheme from their top level container. So when you look at everything that is blue, and you see it's a screenshot that I showed you a few times already, where you have the login and password and so on. That one is still using the base style. Now, the pop-up that you see there that says quit demo, are you sure you want to quit this demo? That one is using the dialog style, right? And you see essentially all the views behave the same because it's posted inside this in a dialog. The text is different, right? And the idea is that it's highlighted, and even if you run it on a VT100, you'll get this inverse style. And then we have a different style for the menu. You don't see here the arrow one, but usually it's on black and white is like strident bold, and on color it's red, right? So you want to use styles for your application. Now there's a bunch of views. It's not as comprehensive as iOS or WPF in terms of views that are built into this. But if you want to contribute, I'll take your patches. It's the kind of thing that you expect from here, from a UI toolkit. Buttons, entries, checkboxes, progress bar, radio buttons. Text field is a one-line editor. Is the one that you see. And text view is a full screen editor. Let me show you that. I don't even know if I have it on this machine. That would be a problem. Where's this? Oh, well, it's not there. Let's see if I can build this. If it doesn't, I might not have this here. Oh, look at that. Well, all right, never mind. I didn't test it on this machine. I have it on the other one. But anyways, it's a full screen text view editor. If I have time at the end, I'll build it with Visual Studio and I'll show you this. But it's a full screen editor. And scroll views are interesting because this is a concept from iOS. A scroll view essentially lets you, you can add views there, and you can control where is the scroll position. And when the views come into display, they'll be shown. Otherwise, it will be hidden, right? So you can completely embed it, the entire application inside of scroll view, and still be able to use menus. Frame view, of course, because I'm a software engineer, there's an X view that gives you an hexadecimal dump that you can use. Then, like I said, those are the views. Now, let's talk about the dialogues. I have a handful of dialogues that are kind of useful. The dialog is just a window, and you can pass a couple of buttons. So the dialog is just a window with buttons, and then you can run this. And it will be modal. And when it completes running, either because you press escape or you manually requested to stop the execution, it will return control. So this application run does not return control until the user is with this. The message box is a variation of dialog. All it does is very common scenarios. I don't want to set up buttons. I don't want to check the set of handlers. Just ask the user yes or no question. Right? It will return a value, which is the index of the option that was selected, or -1 the user canceled. Right? And there's a variation for showing errors as well. All it does changes the style. There's a file open dialog, right? If you want to open files or you want to save files, you can use open dialog, save dialog. The capabilities of these ones, I borrowed those from OS. So it is the kind of APIs that you find in NS Open Panel and NS Save Panel. So it's basically the same stuff, and I kind of copied the the capabilities from there. Have file paths there, whether you can choose directories or allows multiple selection at once. So borrow heavily from there. Uh, one thing that you want to see here when you look at the cancel and open buttons, the open has this. The open button has this additional less than and bigger than signs, and that means that is the default action. So if you press the return key, even if you're not focused, on the open button, it will trigger the open action. Right? So if you press return at any point, it will just trigger the open option, and that gives you the capability of essentially picking something with the cursor, pressing return, and it does what you expect. Now,
Hey, Miguel.
It's thread aware, but it's not thread safe. So one thing that happens, some of my users go and use GUI.cs, and they go and start threads, and then they start poking at the GUI.cs, and they say it doesn't not working, right? Sometimes it crashes if you're lucky, but most often it doesn't work the way that they expect. And the reason is that like almost every UI toolkit in the world, GUI.cs is not thread aware. It's too difficult to make a GUI toolkit thread safe, but it's thread aware. What that means is, first of all, I do provide a sync context. And what that means is that you can just use async and await to your hard content, and the right thing will happen. So just use async and await the way that you would do it with a WinForms or WPF app, and the right thing will happen. Now, some of you don't use task or async or await, or you already have a background thread. So if you really have a background thread, then use this method, application main loop.invoke. And you pass an action. And what that will do is essentially it will cue the action to be executed on the main thread. So when the framework is in a good place to listen to you, right? And typically, and all this does behind the scenes is really add an idle handler for you, a one-shot idle handler that runs your action. And that's how it works. Okay. Now, there's a couple of drivers today.
Can you hear us okay?
I have a driver that uses Anchors as library, the system console driver that uses what .NET provides out of the box. But like I said, it's very limiting. So this is how I started to test on Windows, but it has just too many problems. So I implemented a native Windows driver that has all the capabilities that you need and the proper mouse processing and all of that stuff. In the future, in my copies per time, I will implement, I'm going to get rid of ncurses, because ncurses is, for example, on macOS is shipped with fewer capabilities than it needs, so it limits the spectrum of colors that you can use. So I'm going to be building a new driver for this. Now, if you don't like my API and my view design and all of this stuff, I have good news for you. The amazing Javier Suarez has built a Xamarin Forms backend. So this was supposed to be animated. That is very sad. I don't know how to animate this.
Hey, Miguel.
Well,
Miguel.
I'll publish the PowerPoint so you can see them. But if you go to this website, you can see the animations of these things. And this is effects. Oh, is this animating? No.
Hey, Miguel, we're running a little bit long.
But this is essentially, this is the live previewer of your XAML, right? The thing on the right side is actually a live previewer. So when you press the preview button, it actually shows a preview on the right side of your UI. So this is just Xamarin Forms. The Xamarin Forms that you love on mobile, on Mac, on Windows. Javier wrote a Xamarin Forms backend for the console. And if that's your cup of tea, then you can use Xamarin Forms and build a UI for the console. Now, let's get to creating commands. So you've done all the work. You've done your amazing command line parsing. You've done your line editing for some kind of apps, or you built an amazing GUI app. Now you want to actually use this on your system without having to type .NET run or going to the directory. And
hey Miguel, can you hear us?
Or type a long command line. So what you need to do is you take your console app, right? You take your console app that you just built,
he muted
and you need to do the
us.
following things. You need to give it a package ID.
Probably.
Not all of these are necessary, but just follow my link.
this is good stuff.
I know it's good.
Set a package ID. You flag it as is-tool true, pack as tool true, and then you give it a name, right? My package name is the name that you can use to publish this to Nouget, to the Nouget repository. But the command that you want to type as a user, you typically want it to be lowercase, right? And, so in this particular case, give it the name that you want to use. In this case, it's my tool. And once you've made these changes to your CSproj file, you just say .NET pack, and that will generate your package, right? That will go compile and generate the package. And then you install it with this command, .NET tool install, and then you pass --global, right? And then in this case, I didn't want to add a source, so you just say add source, the bin debug directory, and the package name, and that installs the package into the system. And then you can just use the my tool command at your heart's content. If you don't want this to be global, you can pass the tool path and the directory you want it to be installed. For example, /bin or whatever. This is very so. This is the way that you take your amazing app and make it a system tool. This is similar to what people do with npm, right? So now you have no excuse to not use .NET. If your excuse was, well, npm has -g, well, now you have this thing here, so you can actually write the apps in a decent language. Finally, in the Mono world, we also have this concept of single contained bind executable. So instead of having to have the .NET runtime installed, because this requires you to install the .NET runtime, so we made it so that you could take application and generate a single executable. No dependencies. Everything is embedded into a big fat executable. Every one of your dependencies. And in particular, in this case, this is a bold one. This is actually using Mac APIs. So in this case, I'm linking with absolutely all the Mac APIs and shipping the result. Right. This is my /# command. So all you have to do is call mkbundle /simple and your executable -o, the name that you give to your command. Now, the two secondary libraries have to deal with the fact that this is a library that is using native API. So it's actually a complicated command line. So this is using the Xamarin Mac APIs, and you can see that it embeds and produces this big fat executable, which is almost 10 megabytes big. You can see it at the end. But what is nice is that this is a self-contained executable. You can copy this file and give it to your friends, family, spouses, or kids, and they don't need to install Mono. They don't need to install .NET. This is a self-contained executable. Now we've taken this to the next step, and we said, well, what if you have a Mac, but your daughter has a Raspberry Pi? Well, if you're not, I have a solution. MKBundle can also, right? So you can we support a ton of libraries. In fact, you see that. If you look at the right side on the screenshot, there's little dots. That's because I had to cut the output. There's not enough screen space to list all the target platforms. So I just pasted the last piece, which is Mono.514, and all the target platform you can target from. Again, I couldn't fit everything on the screen, so you get what you get. And so what you have to do is first of all, the system currently has two targets: the default, right? So build, which is what you saw in the previous screen, or demo was something I was testing, or all the targets that are available for download from our server. So what you do is, here I'm going to show you. The first line says, hey, tell me what operating system I'm on. Okay, you're on, it's an iMac, and it's running, it's an x86 machine. That's the first line. So the second line, I say, hey, go get me the target, fetch target, and I tell it the name of the target that I got from the previous screen. So in this case, I want a Mono runtime for Ubuntu 18.04 for ARM64. And then again, I say, hey, give me the list of targets, and it shows that I have it now installed. And then I just say, hey, create me a cross compiler for my command, right? So build me a native executable for that platform, right? So that's what the fourth command does. And finally, it generates this a.out executable. That's what it's saying. That's the default output name in Unix. And then I say, hey, tell me what this a.out executable is, right? So remember, the first line is telling me you're on a Mac, an x86-64 platform. The last line is saying, hey, this is a native executable for an ARM64, right? Using the ELF file format, 64-bit architecture.
Hey, everybody. As
Linux,
you know, we can't get Miguel to respond. I think we're muted on his end. So what we're going to do, we're going to roll into our commercial break and get things situated over here. So thank you so much, and we'll get this content posted, and we'll go from there. Thank you.
Build it on Mac and ship it off to your friends. And